solve the following logarithmic equation. 4 log 3 to base y minus 5 log y to base 3 is equals to 1, isn't it? So just like the other case, when you have log b to base a to be equals to x, then it implies log a to base b is equals to 1 over, isn't it? So what do? If you let log 3 to base y to be x, you say if you let x to be equals to log 3 to base y, then it implies that 1 over x is going to be log y to base 3, isn't it? If you let x to be log 3 to base y, then it means 1 over x is going to be log y to base 3. Then you substitute, isn't it? So can you now substitute 4 times x, because we cannot use the law of logarithm in that they are different bases, isn't it? Are we together? You only use those laws when you have the same base. Is that okay? So here we have 4, this one we've let to be x, then minus 5, it means the reciprocal is 1 over x, isn't it? 5 into 1 over x to be equals to 1. So you multiply both sides of the equation by x. So if you multiply both sides of the equation by x to get rid of this denominator, what do you get? X times 4x, 4x squared, x times 1 over x is 1 minus 5. 1 times x is just x, isn't it? Are we together there? So after that, what do? You bring x this side. So you have 4x squared minus x minus 5 is equals to 0. So you use either quadratic formula or factorization, isn't it? If factorization is not working, you go to quadratic formula. So here we have a product of negative 20 and a sum of negative 1, isn't it? Those numbers are 4 and 5. So which one is negative? 5, isn't it? So it is positive 5 and negative 4, isn't it? Are we together there? So it means here we have 4x squared plus 4x minus 5x minus 5 is equals to 0. If quadratic formula is easier for you, that is what you use, isn't it? So from here, 4x is a common factor here, you remain with x plus 1, isn't it? Here, negative 5 is a common factor, you remain with x plus 1. Because negative into positive, you go back to your negative, isn't it? Are we together? Then the whole of that is equals to? So it means 4x minus 5 times x plus 1 is equals to? So it is either 4x minus 5 which is 0 or x plus 1 which is 0, isn't it? So it is either 4x minus 5 which is equals to 0 or x plus 1 which is equals to 0. So this implies what? 4x is equals to 5, then you divide both sides by 4, you get x is 5 over. Here you take 1 the other side, you get x is equals to negative 1. Then you substitute back the value of x, isn't it? What was the value of x? X was log 3 to base y. So where there is x, you put log 3 to base y, because that was x, isn't it? So log 3 to base y is equals to 5 over 4, isn't it? Are you together? So the best way to solve this, if the base is y, meaning it reduce log y to base y, so that this coefficient becomes the power, isn't it? Then after that, one term, you ignore the log, isn't it? So you end up with 3 is equals to y raised to power 5 over. So for you to get y, you multiply both sides of the equation with the reciprocal of the power of y, 4 over 5, isn't it? So this times this you get 1, isn't it? So there you have y is equals to 3 raised to power 4 over 5, isn't it? Then the second case, x is negative 1. But what is x? X is log 3 to base y. So where there is x, you put log 3 to base y to be negative 1, isn't it? Are we together? So when you solve that, what do you get? Y is the base, negative 1 is the index. So if I solve this with the definition, this one I solve with the law, isn't it? If I solve this by definition, y is the base, negative 1 is the index, 3 is the corresponding number. Then you multiply both sides by negative 1 to get y, isn't it? Then you get y is 3 raised to negative 1. 3 raised to negative 1 is 1 over, isn't it? Good. So you can either solve it by definition of logarithm or by using